Watch this video if you want to get an A star in maths. Let's go. So today I'm going to be going through the third topic you learn about when you get into year 12. So of AS maths, it's called equations and inequalities. I'm going to go through it at a nice and steady pace so that you can keep up. And I'm going to go through all the content you need to get that A star. So before we get started, like, subscribe, comment if you have any queries, and let's get into it. 2kx minus y is equal to 4, 4kx plus 3y is equal to negative 2. Now this is a very similar simultaneous equation to what you would have been exposed to in GCSE. So we need to make 4kx the common factor essentially. So we double the top and we keep the bottom the same. So the top becomes 4kx minus 2y is equal to 8 because we double everything. And then the bottom stays the same, so it's 4kx plus 3y is equal to minus 2. Alright, now essentially we need to get rid of the 4kx's, so we minus them from each other. It doesn't matter which one we minus from the other. So I'm going to minus the top from the bottom, let's say. So you get 0, minus 2y minus 3y is equal to minus 5y. And then 8 minus 2 is equal to 10. Okay, and then y is equal to negative 2. And that, ladies and gentlemen, is your answer. Show that y is equal to negative 2. B, find an expression for x in terms of the constant k. Okay, so we need to rearrange the equation to make x the subject. Okay, so let's get the top one. 2kx minus y is equal to 4. So that means, all right, let's bring the 2kx to one side. So 2kx is equal to 4 plus y. Okay, that means x is equal to 4 plus y over 2k. Okay, and we know y is equal to negative 2 and 4 minus 2 is equal to 2. So x is actually equal to 2 over 2k, and obviously 2 over 2k is just equal to 1 over k, and that, ladies and gentlemen, is the answer to A and B. Moving on. By eliminating y from the equations, x plus y is equal to 2 and x squared plus xy minus y squared is equal to negative 1, show that x squared minus 6x plus 3 is equal to 0. Okay, now it says we need to use elimination, but we don't actually have to use elimination. We need to use substitution. But we need to set y equal to the subject, so y is a subject, and then we need to substitute y into the quadratic, essentially. That's what we need to do. So we know that y is equal to 2 minus x. So then we sub that into the quadratic. So x squared plus xy, so plus x brackets 2 minus x, minus 2 minus x all squared is equal to negative 1. Alright, then what we need to do is x squared plus 2x minus x squared. Okay, then essentially we do minus brackets 4, okay, minus 4x plus x squared is equal to negative 1. Okay, now we've expanded it and we've put it inside the brackets. So that's equal to x squared plus 2x minus x squared minus 4 plus 4x minus x squared is equal to negative 1. Okay, now the x squareds cancel out, so we essentially get minus x squared plus 6x, and then what do we get as the number? We get minus 4 is equal to negative 1, and then that's equal to minus x squared plus 6x minus 3 is equal to 0. Multiply that by negative 1. We get x squared minus 6x plus 3 is equal to 0. And that, ladies and gentlemen, is your answer to part A done. Okay, now we need to show that x and y are given in the form a plus or minus b root x. Okay, where a and b are integers. So obviously we need to use a quadratic formula to solve this. So we do negative b, so negative brackets negative 6 plus or minus the square root of b squared, negative 6 squared, minus 4ac, so 4 times 1 times 3, all over 2 times 1. Okay, now this is the value for x. Okay, and if you put that in your calculator, you get 3 plus or minus root 6. Okay, so what do we need to do? We know that x is equal to 3 plus or minus root 6 now. Okay, so essentially we need to find y. We know that x plus y is equal to 2, so that means 2 minus x is equal to y. So 2 minus 3 plus or minus root 6 is equal to y. So that means 2 minus 3 is equal to negative 1. Hence, y is equal to negative 1 plus or minus root 6. And that, ladies and gentlemen, is your answer. A person throws a ball in a sports hall. The height of the ball, h meters, can be modelled in relation to the horizontal distance from the point it was thrown by the quadratic equation, blah blah blah, it has a negative coefficient of x squared. Remember, if anything has a negative coefficient of x squared, it has a shape like this. The hall has a ceiling which slopes downwards in a straight line, so we're going to have to rewrite this in the form y is mx plus c. initial height of 7.5 meters, and the height of the ceiling reduces by 20 centimeters for every meter of horizontal distance. Now, they've tried to confuse you by changing the units, but you know that the units are in meters, so that 20 centimeters, you're going to have to convert it to 0.2 meters. Right, so H, if we're talking about the ceiling over here, so we know that the y-intercept is going to be 7.5 meters, and it goes down by 0.2 meters each time, so it's going to be negative 0.2 x plus 7.5. And for the other one, we just rewrite it. So h is equal to, I'll write it in decimal form because I prefer decimals. So negative 0.3x squared plus 2.5x plus 1.5. Now essentially we need to determine whether the model predicts that the ball will hit the ceiling. So we set them equal to each other, we work out the discriminant, and then we see what happens then. Okay, so negative 0.3x squared. Now let's simplify it. Okay, so when we simplify it, we get negative 0.3x squared plus 2.7x minus 6. Now let's work out the discriminant. So b squared minus 4ac. So b squared minus 4ac is going to be 2.7 squared. Okay, let's write that down. 2.7 squared minus 4 times by negative 0.3 times by negative 6. Okay, so we get 0.09, which is greater than 0. Hence, it has two roots. Okay, therefore, it does intercept. Okay, so our initial question determined whether the model predicts that the ball will hit the ceiling. Yes, the ball will. B squared minus 4ac is greater than 0. And that, ladies and gentlemen, is that question answered. The curve on the line given by the equations kx squared minus xy plus k plus 1x is equal to 1 and minus k over 2x plus y is equal to 1, where k is a non-zero constant, intersect at a single point. Now, whenever you are observing k's and x's, something should be screaming out towards you. The discriminant, b squared minus 4ac. We know that it intersects at a single point, therefore b squared minus 4ac will be equal to 0. Okay, now we need to find the value of k. How on God's green earth do we do that? Essentially, we know from my previous video on the discriminant that ax squared plus bx plus c is the format of the quadratic needed if you want to use the discriminant. So we need to get rid of this y. So we know that y is equal to 1 plus 0.5 kx. Okay, now we need to substitute that into the quadratic. Okay, so we know the quadratic is kx squared. Okay, minus x times 1 plus 0.5 kx. Okay, plus in brackets k plus 1. That's equal to 1, sorry. So, okay, right, let's expand this. Kx squared minus x minus 0.5 kx squared plus kx plus x and minus 1 is equal to 0. Alright, now we need to simplify this. So, kx squared minus half kx squared, you get half kx squared. So 0.5 kx squared. Okay, so we know that the minus x and the plus x cancel out. So we're just left with the plus kx. And then we've got the minus 1 is equal to 0. Okay, we can double this to get kx squared plus 2kx minus 2 is equal to 0. So we know that b squared minus 4ac is going to be equal to 0. So b squared, so that's going to be 2k squared minus 4 times k times negative 2 is equal to 0. Okay, so 4k squared plus 8k is equal to 0. So 4k brackets k plus 2 is equal to 0. Hence, k is equal to negative 2. Right? Now, give the coordinates for the point of intersection of the line and the curve. Essentially, to find the coordinates, we need to sub in k is equal to negative 2 back into this original equation. So, negative 2 x squared plus 2 brackets negative 2 x minus 2 is equal to 0. Okay, so minus 2x squared minus 4x minus 2 is equal to 0. We can then halve it, so we get minus x squared minus 2x minus 1 is equal to 0. Okay, and now what do we need to do? Well, essentially, we can convert this into x squared plus 2x plus 1 is equal to 0, and therefore we know that this is equal to x plus 1 all squared is equal to 0. Hence, x is equal to negative 1. Right, so we know that x is equal to negative 1. Now we need to find the value of y. So we know that minus half kx plus y is equal to 1. We know that k is equal to negative 2 and x is equal to negative 1. Okay, now we sub those values in. So minus 0.5 times by negative 2 times by negative 1 plus y is equal to 1. Okay, so minus a half times minus 2 is equal to positive 1. Positive 1 times minus 1 is just minus 1. Minus 1 plus y is equal to 1. So y is equal to 2. Find the set of values of x for which 6x minus 7 is less than 2x plus 3. An easy start. Okay, so we bring the x's to one side. We get 4x is less than 10. X is therefore less than 2.5. If we wanted to write this in set notation, we would write, okay, open brackets, x is an element of a real number where x is less than 2.5. Alright, bam, that's an easy start. B, we've got a quadratic equation and it's less than 0. Right, let's factorize it first. That's always the first step, factorize. Okay, so this is our quadratic equation. 2x minus 1 times x minus 5 is less than 0. Right, so now this is fundamental. Okay, this is fundamental. You need to draw the graph. Okay, you need to draw the graph. You can forget your misses at the beach, but you can't forget to draw the graph. Okay, so what is this quadratic going to look like? Okay, so we know one of the roots is 5, right? Okay, and we know that this is going to be equal to a half, okay? Because when you times 2 by a half, you get 1, and 1 minus 1 is 0, so we get a half. And it goes through 5, okay? So that is that quadratic drawn out. Now, if we want it to be less than 0, that means that we need this little section over here. I'm going to highlight it. That's the section we need. So essentially, that means that our x value needs to be greater than a half and less than 5. So when we write it in set notation, it'll be x is an element of a real number where x is greater than a half and less than 5. Now C seems stupidly easy. 5 is less than 20 over x. You just times by x on both sides and then bam, in the game. But actually you don't times by x because x could be negative or positive. You times by x squared because x squared is always going to be positive. So essentially what you do is, okay, see, 5x squared is less than 20x, okay, because we multiplied by x squared, okay. That means that 5x squared minus 20x is less than 0. Factorize it, 5x brackets x minus 4 is less than 0. Okay, now if we draw that out, essentially one of the roots is going to be equal to 0 and one of the roots is going to be equal to 4, so it's going to look something along the lines of that. So if we want it to be less than 0, we need it to be greater than 0 and less than 4. So x is greater than 0, less than 4. And if we write that in set notation, it'll be x is an element of a real number, or we're getting scrunched up here. And then bam, that's your answer. So D, both 6x minus 7 is less than 2x plus 3 and 2x squared minus 11x plus 5 is less than 0. So it's both A and B. So for A, we know that x is less than 2.5. For B, we know that x is less than 5 and greater than a half. So essentially, if we want both of them to follow, that means x is less than 2.5 and greater than a half. Okay, so x is less than 2.5 and greater than a half. Okay, and then obviously I can't be bothered to write that in set notation, but you know how to write it in set notation now.